Hi guys, this is Vikas B and this is a project assignment on tall building design for Skyfi Labs and this is the details of the structure which uh, that I am going to be using. As you can see, the structural plan of the different floors is different and also the live load is also varying for the different structural plans, but the load is same throughout the structure, and I'm going to use M55 concrete FE500 as the longitudinal reinforcement and the mild steel 250 as the confinement bars, and cladding load as 0.2 and slab thickness as 150 mm, and these are the details of the columns and the beams, cross-sectional details which I'm going to be using in this project. So here I've already drawn the structures, defined the material properties, section properties, and also drawn the structural elements in the grid. As you can see now, material properties, M55, 500, M550 is already done, and also it's the same case for the frame sections, beams, columns, and also beam auto select and column auto select respectively, and I've also drawn the structural elements. Now next thing to do is to assign the loads, dead load, live load, and wind load. So now I have selected all the elements and apply the dead load. Story, apply. As I did a mistake before, I didn't select it as similar stories, as live load is different. So for similar stories, now I'm going to select that, and you can see the live load is set to 2.5 everywhere, and also the dead load is assigned to 2 throughout the entire structure. Now let's jump to the next thing I'm going to do is to change the restraints at the base. Now I'm going to apply the cladding load to the external beams. As this cladding load is applied on the beams, so it's going to be a frame load distributed. It's 0.2 kilonewton per meter. Here you can see in the perimeter or the external beams is set to, the cladding load is set to 0.2. In a similar way, I'm going to do for the rest of the structural plan. And the next thing to do is to remove the live load and the cladding load on the top story, as it does not experience live load, and neither it does not experience cladding load on the top, as it is a top story. As you can see, in the 21st floor, the external loads are gone. In a similar way, we have to remove the live loads on the slabs. As you can see, there is a 2 kilonewton per meter square of live load, which I am going to remove it now. As you can see, 21st floor, live loads. There are no live. Now I'm going to define the wind load. 875, 1987 annual load, modify lateral load. For this, the wind coefficients, for the wind coefficients, I'm going to refer IS 875 1987. So as you can see, the wind speed is we can obtain that from the map. As I'm going to design this, as I'm going to assume that this structure is going to be built in Bangalore, so it comes under zone 2. So it's the 33 meters per second, the wind speed, and the terrain category. And it's Bangalore falls under category 3. So category 3, structural class. Structural class depends upon the height of the structure. As this structure, as the height of the structure is 69 meters, as there are 20 floors and each floor height is 3 meters, it is greater than 50 meter. So for that reason, it's class 3. This coefficient, we are going to assume that the mean probable design life of the structure is 50 years. So for that, the K1, that is this coefficient, is 1. So it's set same. And topography, the upwind slope is lesser than 3 degrees. So for that reason, it's going to remain the same, 1, that is 1. Done. Okay. Next thing we have to do is to apply the wind pressure coefficients on the claddings. Section A falls under the windward direction. Assign. Before that, select all stories and select all the shells or claddings. In this case, assign shell loads, wind pressure coefficients. To obtain this value, we have to refer IS 875 again, and it depends on the height to width ratio. And in my case, the height to width ratio comes under 1.575. The value is 1.575, which is greater than 1.5, which falls under which is greater than 3 by 2, that is 1.5. So comes under this. And in this, even in this, there is a subcategory which is for length to width ratio. As the length to width ratio in my case is similar, 40 meters, 8 into 5, 40. So 40 by 40 is 1. So it falls under subcategory 1. So in this case, the coefficients are, for A it's 0.8, for B it's -2.5, -0.25, and for C and D is -0.8. So in the same way, I'm going to do that. As it is a windward direction, it's going to be 0.8 and apply. As the side constant wind pressure coefficient is same in C and D directions, for that reason I'm going to select all the so now all that remains is to assign the load, is to analyze the building structure displacement. Now I'm going to run the design check on the structure. Start design check. the analysis, and also the check is done. Again, go to design, and concrete frame design, and verify all members passed. So all the concrete members are passed now. So we can generate report from the E-tab analysis. So project report, we can have that, and these values are the longitudinal reinforcements values at that sections, at the top and bottom, at the supports too. So, and also I can access each and every member data from here. So here you can see the longitudinal reinforcement area, major shear reinforcement, and minor shear reinforcement. So we can see how we can access the data from here. And project report, also we can generate the summary report of the project. And that's it. Thank you.